Chapter 9 Coordination Compounds, 12th Chemistry. Important questions for board exam. And see the question. In which of the following compounds oxidation state of metal is 0? The correct option is CrCO6 because carbonyl is a neutral ligand. Example of DsP2 hybridization is it is found in NiCN4 minus 2. Which of the following complex is used as anti-cancer agent? It is cis PTNS3 2Cl2. Oxidation state of Fe in FeCO3 complex is because CO3 carbonyl is neutral ligand, so the oxidation state of iron is 0. Structure of complex salt was proposed by Werner. Mohr salt is a example of double salt. The IUPAC name of NiCO4 is it is tetracarbonyl nickel 0. Now see the fill in the blanks. Cis PTNS3 2Cl2 complex is used as an anti-cancer agent. Hemoglobin is a complex compound or coordination compound. Geometrical isomerism is found in both tetrahedral and octahedral complexes. Oxidation state of Ni in NiCO4 is 0 because carbonyl is a neutral ligand. Diethyl zinc is a organometallic compound. The correct IUPAC name of K4FeCN6 is it is potassium. फिर hexa Cn is known as cyano, and then it is ferrate, hexacyanoferrate, and the oxidation number is second. It is calculated such that the negative charge is present in Cn. For 6 Cn, there is 6 negative charges and 4 positive charges given by K. So this is a 4 plus given by potassium. The left charges is -2 and it is neutralized by Fe. So the its oxidation state is 2. Oxidation state of cobalt in cobalt EDTA, it is +3. The formula of dibromochlorotriaquachromium third is here dibromo, this is dibromo. Next chloro, this is chloro. Tri, this is tri. Aqua, it is written is H2O, and chromium, it is chromium. And the charge are -1 charge is present in Cl and -1 charge in present in Br, but the molecules of Br are 2, so there are 3 negative charges which are neutralized by Cr. Thus, the oxidation number is 3. COF6 -3 is a high spin complex. The formula of anti-knock organometallic substance is tetraethyl lead. It is C2S54Pb. EDTA is a hexadentate ligand. Now next question is match the following. Example of bidentate ligand is it is C2O twice. Neutral ligand is it is CO carbonyl. Coordination number of CO in CONS346, it is a ligand, 4 ligands, and this is 2 ligands. Total number of ligands is 6. The coordination number is 6. Ambident ligand is ambident ligand which can give both pair of electrons. Both atoms are capable of giving lone pair of electrons. These are known as ambident ligand, and this is Na2 and HCN. Number of primary and secondary valency in number of secondary valency is this 5 ligands and Cl. This is 6 ligands are secondary valency, and -1 charge is present in this, -1 charge is present in this, total -2, and it is completed by CO. Thus it is 2 and 6. This option is correct. Number of primary and secondary valency in CONS3 6 and Cl3. The coordination number is 6, secondary valency is 6, and the primary valency is 3, so it is 3 and 6. Alkyl magnesium halide. Alkyl magnesium halide is a organometallic compound. Dichlorotriamine platinum. It is an example of cis and trans isomerism. Answer in one word sentence. Which type of isomerism is found in CONS35Br SO4 and CONS35SO4Br? Here CO is small o and it is also small o, stand for cobalt. It is a ionization isomerism because there is exchange of ion from outer side of complex to inner side of complex. Now next question, name the organometallic compound which is used as an anti-knock compound in petrol. It is tetraethyl lead. Complexes of EDTA formed with calcium is used to remove the poisoning cause due to which metal? It is lead metal. How is the structure of dibenzene? It is like a sandwich. What type of hybridization is found in NiCO4? It is sp3. Which type of isomerism is represented by CrH2O5 SCN and CrH2O5 NCS? The donating atom is changes, so it is a linkage isomerism. Now the questions which is asked in 2, 3, 4 marks. Explain double salt and complex salt. Give one example of each. Let us see double salt. Double salt are additive compounds which are stable in the crystal lattice but when dissolved in water break into different compounds. Example FeSO4, NH4, 2SO4, H2O. Next is complex salt, the compound in which ligand with lone pair electron are linked with any metal atom or a metal ion by coordinate bonds are called coordination compounds. In these compounds, metal ion and ligand in combined state act as complex ion and thus these compounds are also known as complex compounds. Example is K4 in bracket FeCN6. Next question, what do you understand by ligand? Explain giving example. Ligand, any atom, ion or molecule which can donate electron pair to the central ion or central atoms to form coordinate bonds are called ligand. Example in K4 FeCN6, Cn is a ligand. What is meant by chelate effect? Give an example. When a ligand attaches or linked to the metal ion in a manner that forms a cyclic ring, then this compound is known as chelate. Example, this is the structure of chelate here. These are the ligand and these are metallic ion and they form a cyclic structure or ring. This compound is known as chelate. Now next question is what is complex ion? A complex ion is an electrically charged radical carrying either positive or negative charge in which the central metal ion is surrounded through coordinate bond by ligands. तो ये टोटल लिगेंड के ऊपर जो भी चार्ज होता है वो कॉम्प्लेक्स आयन कहलाता है। तो ये सेंट्रल मेटल है, सेंट्रल आयन है, सेंट्रल मेटल है और ये लिगेंड है। इसको सराउंड करने के बाद जो भी यहाँ पर आयन आएगा वो कॉम्प्लेक्स आयन कहलाएगा। Give an example of bidentate and hexadentate ligand. Bidentate ligand which can give two pair of electrons to the central atom. Here N and this N can donate electrons. Hexadentate in which six atoms are capable of donating electrons in pair, that is O, O, N, N 4 हो गए और ये कितने हो गए 6 हो गए. What is coordination number? Give any two examples. Number of ligands which are directly linked with the central metal or ion by coordinate bonds are called coordination number. यहाँ पर एग्जाम्पल है CONH3, NH3 6, Cl3. Here the number of ligand is 6, so the coordination number is 6. AgCN2. Here number of ligands is 2, so the coordination number is 2. Next question. What are organometallic compounds? Write its two properties. Those compounds in which the carbon atom of organic groups are directly bonded to the metal atoms are called organometallic compounds. Applications of organometallic compounds are tetraethyl C2H54BB PB is used as an anti-knock compound. Ziegler-Natta catalysts is used in the polymerization of ethylene or other alkenes. Ethyl mercury chloride C2H5HgCl is used in agriculture as an insecticide. Wilkinson catalyst is used in the hydrogenation of the some alkanes. FeH2O 6 is strongly paramagnetic, whereas FeCN6 3- is weakly paramagnetic. In both complexes, F is in +3 oxidation state with the configuration of 3d5. Cn is a strong ligand and its presence 3d electrons pair up leaving only one unpaired electrons. The hybridization is T2sp3 forming inner orbital complex. In H2O is a weak ligand. In presence, 3d electrons do not pair up. The hybridization is sp3d2, forming an outer orbital complex containing 5 unpaired electrons. Hence, it is a strongly paramagnetic because if the number of unpaired electrons in transition metals are more, then they are more paramagnetic. Next question. Write the IUPAC name of following coordination compounds. अब यहाँ पर हमारे पास CONH3 6Cl3 है, तो इसका नाम देखते हैं. 6 मीन्स हेक्सा, NH3 मीन्स एमीन, CO मीन्स कोबाल्ट एंड Cl3 means chloride. Now, how to calculate oxidation number? Amine is a neutral ligand, whereas Cl3 a negative ligand which contains one negative charge. 3Cl has -3 charges, which is completed by CO. Thus, its oxidation is 3. Now, second, for this 5 है तो ये हो गया पेंटा. Next, NH3 is a amine, Cl3 is a chloride. Now CO is a cobalt. There are three chlorine. Each chlorine has one negative charge. Thus, there are three negative charges, which is completed by cobalt. So, its oxidation state is 3 because NH3 is a neutral ligand. Next, this name is first, that is potassium. Next, 6 hexa, Cn is cyano and Fe is फेरेट. अब यहाँ पर लिगेंड सी एन में एक माइनस है तो कुल मिला के 6 माइनस हो जाएंगे. 6 माइनस में ये पोटेशियम +3 रहता है, इसके पास एक पोटेशियम +1 है, 3 पोटेशियम 3+. यहाँ पर जो ऑक्सीडेशन स्टेट होगी वो 3 हो जाएगी, -3 आएगा तो +3 एफ से होगा. तो इस तरह से यहाँ पर Fe3 लिखेंगे. दूसरा जो इसका जो है कॉम्प्लेक्स आयन का जो टोटल चार्ज हो निगेटिव आएगा, इसलिए यहाँ पर फेरस न लिख करके आयरन न लिख करके 8 लगाते हैं, फिर 8 हो जाएगा. नेक्स्ट देखिए यहाँ पर ये है K3, इट मीन्स इट इज़ पोटेशियम. फिर ये Tr3 है, ट्राई. C2O4 इज ए ऑक्सलेटो, so trioxylato, and again ferrate because C2A4 has 2 minus, then 3 ligands, it means 2 minus into 3 equal to हो गया -6, plus 3 is taken by potassium, so it remains -3. The complex ion charge is minus, so it is written as ferrate and its oxidation state is 3. Next question, explain the structure of NiCO4 on the basis of valence bond theory. Nickel has 28 electrons and the outer orbit is arranged such that 3d has 8 electrons and 4s has 2 electrons. These electrons paired in this form and 4s orbital is empty. Now number of ligands is 4, So 4 orbitals are required to form the complex compound. So 1 orbital of s and 3 orbital of 4p are hybridized to form sp3. This is 4s 4p and orbital name is sp3 hybridized. Now CO4 carbonyl 4 carbonyl are uh, attached with the metallic ion and form two 4 covalent bonds by giving 4 pair of electrons which are filled in these sp3 orbitals. It has sp3 hybrid orbitals and pair electrons, thus it is a dimagnetic and tetrahedral. Explain the structure of zinc NH342 plus ion on the basis of valence bond theory. Zinc has 30 atomic number and its electronic configuration of outer orbit can be written as this. In ionic state, 4s electrons are removed from the zinc atom and only 3d electrons are present. We have 4 ligand, so we need 4 hybridized orbitals. This is 4s and this is 4p and they are hybridized to form sp3 orbitals. Now this ligand are connected with the metallic atom with the coordination bond and 4 pairs of electrons is donated by it which is filled in sp3 orbital. Thus it has sp3 hybrid orbitals and paired electrons, thus it is a dimagnetic and tetrahedral. Write IUPAC name of the following. Now this is di, 2 means हो गया डाई, Cl क्लोरो, 3 ट्राई and amine. I have corrected it is 2, so it is diamine. Now platinum and number of oxidation, how it can be find. The chlorine has -1 charge, 2 chlorine has -2 charge, it means platinum will give is +2 charge, thus its oxidation is 2. Now name of this, first of all we take the name of potassium, so it is potassium. Now hexa, then cyano or then ferrate. The oxidation number is 3 because Cn has 1 negative charge, there is 6 Cn, it means -6 negative charge and 3 plus charge is given by K potassium, so left charge is -3. The complex ion is -3, so 8 is inserted in the name of ferrous and the oxidation number is also 3. Now platinum, this is platinum. First of all this is hexa, then amine, then platinum and then chloride, and oxidation number is 4 because Cl has 1 minus, there are 4 minuses which are uh, completed by platinum, so its oxidation number is 4. Using IUPAC norms, write the formulas for the following. And now there is a word in which we will write formula for these. This is tetra, this is tetra, it means 4. Then hydroxo, this is OH. Zincate, this is Gn and 2, that is -2. 8 लगा है इसलिए हम माइनस लगाते, यदि सिर्फ जिंक लगा होता तो प्लस में लिखते। नेक्स्ट देख लीजिए यहाँ पर क्या है, पोटेशियम, सो इट इज़ रिटन इन के, देन टेट्रा, दिस इज़ 4, क्लोरो, दिस इज Cl and this is palladate, that is Pd, and second, so 2 charges are given to K2 and 2 charges are given by Pd and Cl4 has -4 charge. Now next is potassium, this is K, tetra, this is 4, cyano, this is Cn, and nickelate, this is Nn. Cn has 4 minus, 2 are taken by Ni because its oxidation number is 2, and 2 is taken by K2. Write the IUPAC names of the following compounds. This is tetra, then I for iodo, next mercury, but it has negative charge, so 8 is given to it. It is mercurate, and 2 minus second ion. Next is di for 2, cn, cyno, then argentate 8, यहाँ पर फिर माइनस है इसलिए यहाँ पर 8 लगा है, एक आयन है तो यहाँ 1 लिख देंगे। नेक्स्ट है यहाँ पर देख लेते हैं, ये बिस हो गया, बिस साइक्लोपेंटिडीन नाइल, ये साइक्लोपेंटिडीनाइल हो गया, और एफ है तो एफ के लिए आयरन हो गया, और इसमें 2 माइनस होते हैं तो ये 2 इसका ऑक्सीडेशन नंबर हो जाएगा। नेक्स्ट इज़ पोटेशियम, देन डाई, देन साइनो, and then argentate. Next question is, what is effective atomic number? In coordination compounds, sum of electrons present in central metal ion and electrons received in bond formation, covalent bond formation, is called effective atomic number. That is EAN equal to electrons present in central atom plus electrons obtained in bond formation by ligand. For K4 Fe En for the atomic number of Fe is 26, its oxidation number is 2, so it is minus 2, and number of electrons obtained by ligand, there are 6 ligands and they give 2 electrons, the total number of electrons is 12, so the En number is 36. Now next question is, explain the bonding in coordination compounds in terms of Werner's postulate. Alfred Werner gave coordination theory. The important postulates for this theory are: all metals in atomic or ionic form exhibit two types of valencies in a coordination compound. First one is primary or principal or ionic valency, and other is secondary or auxiliary or non-ionic valency. The primary valency is ionizable and it is shown by dotted lines. The secondary valency is non-ionizable and it is shown by the continuous lines. Primary valency represents oxidation state of metal atom or ion, and secondary valency represents the coordination number of metal ion which is fixed for a particular atom. The primary valencies are satisfied by negative ions or positive ions, negative ions, whereas the secondary valencies may be satisfied either by negative ion, positive ion, or neutral molecules. Secondary valencies are directed towards fixed position in space and they have a specific geometry. Every element tends to satisfy both in primary and secondary valencies. For this purpose, a negative ion may often act as dual behavior. It may satisfy primary as well as secondary valencies. List various types of isomerism possible for coordination compounds, giving an example of each. Isomerism in coordination compounds: two or more compounds having the same molecular formula but different arrangement of atoms are called isomers. There are two types of isomerism. It is structural isomerism and stereoisomerism. Structural isomerism further divided into ionization isomerism, coordination isomerism, linkage isomerism, and hydrate isomerism. Whereas stereoisomerism is further divided into two: geometrical isomerism, which is cis or trans isomerism, and optical isomerism. Let us see each. इनके एग्जाम्पल्स भी आपको देखना है, एग्ज़ाम में दोनों में से कोई भी ऐसे करके पॉइंट वाइज भी अलग अलग भी पूछे जा सकते हैं, वन बाय वन. Structural isomerism. This type of isomerism arises due to difference in structure of coordination compounds. It is further subdivided into four different types of explained below. First is ionization isomerism. This type of isomerism is shown by such compounds which have same composition but liberate different ions in the solution. This is CONH3. Again, CONH3 5BrSO4 to liberate SO2 ions in the solution. In CONH3SO4Br, here the exchange of ions. This ion insert in the complex and this ion is out to the complex. It liberates Br ions. So they have the same formula but different structure according to exchange of ions. So it is known as ionization isomerism. Coordination isomerism. This type of isomerism is shown by such compound which contain both cationic and anionic species, and it arises from the interchange of ligands between cationic and anionic entities of different metal ions present in a complex. For example, यहाँ पर देख लीजिए हमारे पास यहाँ टू लिगेंड्स हैं और टू जो है कॉम्प्लेक्स संकुल हैं एक साथ हैं, इनमें जो है लिगेंड का एक्सचेंज हो जाता है। ये Cr के साथ NH3 जुड़ जाएगा, NH3 के साथ Cr जुड़ जाएगा। तो इस तरह का जो होता है उसको हम बोलते हैं कोऑर्डिनेशन आइसोमरिज्म। इसमें जो है कोऑर्डिनेशन कंपाउंड में जो लिगेंड होते हैं वो दूसरे दूसरे मेटलिक एटम से लिंक हो जाते हैं। नेक्स्ट है लिंकेज आइसोमरिज्म। Linkage isomerism occurs when different atoms of the ligand are attached to the central metal ion. The structure obtained are called linkage isomers. Such type of ligands are called ambident ligands. यहाँ पर देखिए NH3C, यहाँ पर जो है SCN, S is directly connected to the nickel, and in NH3 5 NCS, N is directly connected to the nickel. So there is a linkage isomerism because in this S is connected with nickel and in this N is connected with the nickel. Now hydrate isomerism. This isomerism arises when different numbers of water molecules are present within and outside the coordination sphere. For example, 3 hydration isomers of CrCl36H2O are CrH2O6Cl3, it is violet, CrH2O5Cl, there is Cl यहाँ 3 था, अंदर एक Cl गया तो 2 हो गया, H2 बाहर आ गया, ये हो गया ग्रीन। CrH2O4, Cl एक और अंदर चला गया, एक Cl यहाँ बचा, 2H2, ये क्या है एलो। तो यहाँ पर देखिए कोऑर्डिनेशन जो नंबर है वो सेम है, सब में 6 है, पर यहाँ पर जो ये जो वाटर मॉलिक्यूल है उसका लोकेशन डिफरेंट है, कभी लिगेंड और कभी ये बाहर आ जाता है इसके कंपाउंड स्फीयर के बाहर। Next is stereoisomerism. Two compounds are called stereoisomerism when they contain the same ligand, their coordination sphere, but differ in their spatial arrangement. Stereoisomerism is further classified as geometrical and optical isomerism. First of all, see geometrical isomerism. When the ligand are situated at different positions around the metal, it gives rise to geometrical isomerism. The isomer in which similar groups are in adjacent position, making an angle of 90 degree with metal ion, is called cis isomer. The isomer in which the similar group occupy the opposite position, making an angle of 180 degree with the metal ion, is called trans isomer. This type of isomerism is observed in square planar, coordination number is 4, and octahedral, coordination number is 6. Now see the examples NH3 and NH3. They are at 90 degree, so it is cis. NH3 and NH3. They have angle is 180 degree, so they are trans. In this NH3 and NH3 have angle of 90 degree. This structure is cis, and यहाँ NH3 and NH3 they are opposite to each other and forms an angle of 180 degree, so they are in trans position. Next, optical isomerism. This type of isomerism is observed in such similar compounds which are the mirror image of each other and are non-superimposable. They rotate the path of plane polarized light to left or to the right. तो यहाँ पर ये है और ये भी लिगेंड है और ये जो है एक दूसरे के, ये जो कॉम्प्लेक्स कंपाउंड है एक दूसरे के मिरर इमेज है। यदि इसके सामने आईना रख दे तो इस तरह से ये इमेज फॉर्मेशन होता है, इसको ऑप्टिकल आइसोमेरिज्म कहते हैं। नेक्स्ट, एक्सप्लेन क्रिस्टल फील्ड थ्योरी. दिस थ्योरी वॉज प्रपोज्ड बाय बेथे एंड वॉन ब्लैक. According to this theory, bonding between central metal ion and ligand is due to pure electrostatic attraction. Thus, bonding between them is due to ion-ion attraction or ion dipole attraction. And this is the figure in which their metallic state is divided into two parts. One is excited state and one is ground state. In crystal field theory, due to approaching ligands, the d orbitals split into two different energy levels. On the basis of extent, splitting depend on the metal ion nature of the ligand, structure, and properties of complex can be discussed. Color of transition metal complex is due to absorption of visual light, which leads to excitation of electron from one d orbital to other d orbitals, that is dd transition. This way, this theory is easy and successfully explains maximum properties of the complexes. Now calculate the oxidation number of central ion. फर्स्ट ऑफ ऑल PtNH3Cl माइनस, तो यहाँ आप Pt के लिए क्या लिखेंगे, x लिखेंगे, और 1 एटम है तो 1 लिख देंगे। यहाँ पर NH3 का जो है ऑक्सीडेशन 0 हो और इसमें 3 है तो यहाँ पर 3 लिख देंगे। और इसके बाद ये Cl है, Cl का -1 होता है, यहाँ 3 है तो 3 लिख देंगे। और पूरे कॉम्प्लेक्स का जो है ये -1 है तो -1, यहाँ यदि कुछ ना होता तो फिर 0 लिख देते। इसको इस तरह से हम सॉल्व करेंगे तो x की वैल्यू +2 आ जाएगी, तो यहाँ पर ऑक्सीडेशन स्टेट +2 हो जाएगी। सिमिलरली यहाँ पर देखते हैं Zn में Zn के लिए हम x लिखेंगे, ये 3 है तो यहाँ 3 लिख लिए, इसकी ऑक्सीडेशन 0 होती 0 लिख दिए। OH का ये माइनस है यहाँ OH का, तो यहाँ पर जो है ये यहाँ माइनस होता है OH में तो -1 ले लेंगे, और ये बाहर का +1 है तो +1 ले लेंगे। इसको सॉल्व कर देंगे तो ये x इक्वल टू +2 आ जाएगा, तो इसकी ऑक्सीडेशन स्टेट +2 हो जाएगी। नेक्स्ट में देखते हैं Na4 NiCN4 में, इसमें देखते हैं Na, तो यहाँ पर ये Na की +1 होती है और यहाँ 4 है तो 4 ले लिए। Ni की हमको फाइंड करना है तो x ले लेते हैं, 1 आइटम है तो 1 ही ले लेते हैं। अब यहाँ पर जो 4 है तो ये 4Cn है, 4 लिख लिए। इसकी जो ऑक्सीडेशन नंबर होती है -1, इस तरह से इस वैल्यू को जब हम सॉल्व करेंगे तो x की वैल्यू 0 आ जाएगी, तो यहाँ ऑक्सीडेशन स्टेट निकल के 0 हो जाएगी। नेक्स्ट K2ZnOH4, तो यहाँ पर ये 2 है तो 2 लिख दिए, K की +1 होती है +1 लिख देंगे। जिंक के लिए हम x लिख देंगे, 1 एटम है तो 1 लिख देंगे। फिर यहाँ पर OH का -1 होता है, 4 है तो यहाँ पर 4, फिर इसको सॉल्व करेंगे इसी तरह से, तो x इक्वल टू क्या हो जाएगी +2 ऑक्सीडेशन स्टेट हो जाएगी। नेक्स्ट यहाँ पर भी हम देखते हैं, फिर से है कैलकुलेट ऑक्सीडेशन नंबर ऑफ सेंट्रल आयन। जिसमें हम देखते हैं यहाँ पर ये कोबाल्ट है, कोबाल्ट के लिए हमने x लिख दिया। H2O का है ये, इसका 0 होता है, और यहाँ पर जो Cn का होता है वो -1 होता है, En का 0 होता है उसको हमने लिखा नहीं, और यहाँ पर ये +2 है तो +2 है। इसको सॉल्व करेंगे तो x की वैल्यू जो होगी +3 आ जाएगी। यहाँ पर देखते हैं कोबाल्ट के लिए हमने x लिख दिया। अब यहाँ पर Br है तो Br का यहाँ पर देख लेते हैं, यहाँ CO का हमने x लिख दिया, Br का 4 है 4 लिख दिया, इसमें -1 होता है तो -1। En जो है ये न्यूट्रल है, इसको लिखने की ज़रूरत नहीं है। और यहाँ पर जो हमारा टोटल है उसको देख ले, तो यहाँ पर फिर से देख लेते हैं, ये CO के लिए क्या हो गया, x हो गया। ब्रोमीन 4 है 4 कर लिए, ब्रोमीन में 1- होता है तो 1- लिख लेंगे। ये इसका जो आयन है -2 है -2, इसको सॉल्व करेंगे तो +2 आ जाएगा। अब थर्ड में देखते हैं, Pt के लिए हमने क्या लिख दिया, x लिख दिया। क्लोरीन 4 है तो यहाँ 4 कर दिया, यहाँ पर 1- होता है -1, और इसका जो है 2- है तो ये -2 लिख करके इसको सॉल्व करेंगे तो x इक्वल टू +2 आ जाएगा। अब यहाँ पर हम देख लेते हैं ये फोर्थ नंबर का K3 है तो ये 3 हो गया, इसमें +1 होता है तो 1 लिख दिए। यहाँ पर हमको प्लस लगा देना है, और इसके बाद यहाँ पर Fe की x लिख देंगे। Cn6 है तो ये 6-1 लिख देंगे, इसको सॉल्व करेंगे तो इस तरह से आ जाएगा। इसी तरह से नेक्स्ट वाला हमको देखना है Cr के लिए हमने x लिख दिया। NH3 का कुछ होता नहीं है, न्यूट्रल है, तो Cl3 के लिए 3- इस तरह से लिख दिया, और इसका वैल्यू 0-0, इसको सॉल्व करेंगे तो +3 आ जाएगा। In this way you can calculate oxidation number of any coordination compound. Now the question is explain MP-dentate ligand with example. When a monodentate ligand has two donor atoms and they bind separately with the central metal ion to form a coordination bond, then they are called ambidendant ligands. Example, this is nitro. In this, N can donate electrons to the metal and also O can donate the electrons to the metal. This ligand is known as ambidendant ligand. So thank you. Practice this, share this and subscribe the channel.